Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. This is part 2 video on the chapter rational numbers, where I will solve the problems question number 1 to question number 6 from the exercise 1A from the textbook of author RS Aggarwal. So this video is part of the playlist CBSE Maths for class 8 following the textbook of author RS Aggarwal. If you are new to my channel or not yet subscribed, and if you are watching my videos regularly and my videos are beneficial to you, then I strongly suggest and request that you please support me by subscribing to my channel, and also please do not forget to press the bell icon so that you will be notified by my future videos. So let's get started with this video. Okay, so I have the problems exercise 1A, a screenshot of the problems of exercise 1A on the left hand side, and on the right hand side I will solve the problems. There are total 11 questions in this exercise 1A, and in this video part 2 I will solve question number from question number 1 to 6, and the remaining 7 to 10 I will solve in the next video, that will be part 3. So let's start solving the problems. The first problem says express minus 3 by 5 as a rational number with denominator 20, minus 30, 35 and minus 40. Okay, so this is question number. Let's do part 1. So we have to convert this rational number minus 3 by 5 with a denominator 20. So how do we do? So we have to make the denominator 20. The denominator is 5. So we have to multiply 5 with 4 to get 20. Now we know that in the previous video, if you have not watched the part 1 video where I talked about the properties, comparisons and the standard form of rational numbers, I highly suggest that you watch that video also to maintain the continuity of your study on the chapter of rational numbers. So we know that any rational number, if you multiply both the numerator and the denominator with the same non-zero number, it remains the same. So we can, to make the denominator 20, we have to multiply 5 with 4. So we can multiply both the numerator and the denominator with 4, and the rational number remains same, but the denominator becomes 20. So this is minus 12 by 20. So the rational number minus 3 by 5 is equivalent to the rational number minus 12 by 20, but it has a denominator 20. Okay. Part 2, we have to make the denominator minus 30. So we know that to make denominator 5 to minus 30, we have to multiply with minus 6. So we will multiply both the numerator and the denominator with minus 6. So we have now this equivalent rational number, minus 3 into minus 6 is 18, and the denominator 5 into minus 6 is minus 30. So 18 by minus 30 is the equivalent rational number of minus 3 by 5, and it has a denominator minus 30. Okay, let's see part 3. We have to make the denominator 35. So clearly we have to multiply 5 with 7. So this becomes, and we have to multiply to make the denominator 35, we have to multiply the denominator 5 with 7. So to keep the rational number equivalent or same, we have to multiply both the numerator and the denominator with 7. So this becomes minus 3 into 7 and 5 into 7. This is minus 21 by 35. So minus 21 by 35 is the rational number, the denominator 35, which is equal to or same as minus 3 by 5. Okay. Part 4, we have to make the denominator minus 40. So clearly we have to multiply both the numerator and the denominator with minus 8. The denominator is 5. To make it minus 40, we have to multiply it with minus 8. So the minus 3 by 5 rational number can be written as or its equivalent rational will be minus 3 into minus 8 divided by 5 into minus 8. This is equal to minus 3 into minus 8 is 24, 24 by minus 40. Okay, so this was simple. This was just to make the denominator some specific number, and we have to since all the given numbers, all the given denominators are multiples of 5, so we have to multiply the denominator of the given rational number minus 3 by 5 with some non-zero integer, and if the denominator was greater, if the given denominator was greater, and we have to convert it to a rational number, equivalent rational number with less denominator, we have to divide both the numerator and the denominator with some suitable non-zero number. Okay, let's do problem number 2. Problem number 2 says express minus 42 by 98 as a rational number with denominator 7. So we can see that the given rational number is minus 42 by 98, and we have to convert this rational number so that the denominator becomes 7. Now denominator with denominator 7, now we have to see with what number we can divide. The denominator in the given rational number is 98. Now by what number we can divide, let's say that number be m, so that we get 7. Then we can divide both the numerator and the denominator with m, whatever that m will be, and we will get the denominator, we will get an equivalent rational number with denominator 7. Now we have to find m, that is, if I divide 98 by m, it should give 7. Now this implies, this is a kind of side calculation, this implies that m should be 98 by 7. This is equal to 14. So if you divide 98 by 14, we will get 7. So we can write using the property 2, that is, if you have a rational number, we can divide both the numerator and the denominator with some number, with some non-zero integer, and the rational number remains the same. So if you divide, now since it has asked to convert this rational number so that the denominator becomes 7, it has not asked to convert this rational number into a standard form. If the question was to convert this rational number to standard form, then we would have to find the HCF of 42 and 98. But in this case, it is asking to convert the denominator to some number, lesser number, that is 7. So we will just divide. Divide 98 by 7, and whatever the number is, in this case m, which is 14, we will divide both the numerator and the denominator by the number, that is 14. So this we can write minus 42 divided by 14, and this will be 98 divided by 14. So minus 42 divided by 14 is minus 3, and 98 divided by 14 is 7. So the rational number is minus 3 by 7, which is equivalent to the rational number minus 42 by 98. But the right hand side rational number has a denominator 7. Okay. Question number 3. So while I am solving the problem, you can pause the video and take screenshot for your future reference if you think it will be useful to you. Question number 3. Express minus 48 by 60 as a rational number with denominator 5. So we have to convert minus 48 by 60 so that the denominator becomes 5. Now how do we so we have to, we see the denominator is 60, so we have to divide 60 by some number so that it becomes 5. So what will be that number? By what number we divide 60 so that it becomes 5? So we have to find m. From here, from this kind of equation, we know that m is equal to 60 by 5, which is 12. So if we divide 60 by 12, we get 5. So we can convert this rational number to its equivalent form by dividing both the numerator and the denominator by 12. Why 12? Because if we divide 60 by 12, we will get 5, and it has asked to make the denominator 5. 60 by 12. So this becomes, for minus 48 divided by 12 is minus 4, and this is 5. So the rational number is minus 4 by 5, which has a denominator 5 and which is equivalent to the rational number minus 48 by 60. Okay. Problem number 4. Problem number 4 says express each of the following rational numbers in standard form. So we have to find the rational numbers, given rational numbers, into standard form. The first one is minus 12 by 30. We see the denominator is positive, it's fine, it's first condition. So the rational number p by q is in standard form if there are two conditions. The denominator, that is the q, has to be greater than 0, and the p and q should not have any common divisor. The absolute value of p and q should not have any common divisor, that is the HCF of absolute value of p and q should be 1. Now we see here that HCF of the absolute value of the numerator and the denominator, the numerator is minus 12, so its absolute value is 12, and the denominator is 30, so 12 by 12 and 30, the HCF of 12 and 30 is how much? 6, I guess. It is 6. Okay. Now, so we know that how do we convert a given rational number to its standard form. First we check that the denominator is negative or not. In this case it is not. If it was negative, then we will first make the denominator positive by multiplying both the numerator and the denominator with minus 1. In this case the denominator 30 is already positive. So now we will just divide both the numerator and the denominator by their HCF. That is the HCF of the absolute values of the numerator and the denominator, which in this problem is 6. So we have this number, rational number, is equivalent to, we will divide both the numerator and the denominator by 6. 30 by 6. This becomes minus 12 divided by 6 is minus 2, and minus 30 and 30 divided by 6 is 5. So minus 2 by 5 is the rational number standard form of the rational number, given rational number minus 12 by 30. Okay, let's see part 2. The rational number we have to convert in standard form is minus 14 by 49. Now first we see that the denominator is positive, that is fine, but we can see that the HCF of the absolute values of the numerator and the denominator is not 1, because we know that at HCF of that the numerator is minus 14, so its absolute value is 14. Its absolute value is 14, so we have to see whether the HCF of 14 and 49 is 1 or not. If it is all 1, then we did not do anything, but we can see that the HCF of 14 and 49 is 7, which is not equal to 1. So we will divide both the numerator and the denominator by the HCF, that is 7. That is 7, and we get this is equal to minus 14 divided by 7 is minus 2, and 49 divided by 7 is 7. So we have minus 2 by 7, which is the rational number in standard form of the given rational number minus 14 by 49. Okay. Let's see the rational number part 3. It is 24 by minus 64. Now we see that the denominator is negative, minus 64 is negative. So first we have to make the denominator positive by multiplying both the numerator and the denominator by with minus 1. So this becomes minus 24 by 64. Now we see that the HCF of the absolute values of the numerator and the denominator is not equal to 1. If it is 1, we need not do anything else. But we can see that HCF of 24 and 64, 24 is the absolute value of minus 24, is equal to how much? I think it's 8. 8. So minus 24, to convert the rational number minus 24 by 64 in standard form, we will divide both the numerator and the denominator by the HCF of 24 and 64, which is 8. 64 divided by 8. So this becomes minus 24 divided by 3 by 8 is minus 3, and 64 divided by 8 is 8. So minus 3 by 8 is the answer, which is the rational number in standard form of the given rational number 24 by minus 64. Part 4 is minus 36 by minus 63. Even though you may see that the denominator is negative, but you can also see that the numerator is also negative. So in a rational number, if both the numerator and the denominator are negative, then you can cancel out the negative, and you can see the rational number will be a positive one. So in this case, we can cancel out the negative, and we can say that this rational number is equal to 36 by 63. If both the numerator and the denominator are negative, then only you can cancel out the negative sign. Okay, now we can see that the HCF of the numerator and the numerator is 36 and the denominator is 63, the HCF is not equal to 1. Now what is the HCF? The HCF is, I think, 9. HCF of 36 and 63 is 9. So we have to divide. Both the numerator and the denominator with 9. 36 divided by 9 divided by 63 divided by 9. This is equal to 4 by 7. So 4 by 7 is the rational number in standard form of the given rational number minus 36 by minus 63. So let me circle the answers. This is minus 3 by 8, and we have minus 4 by 5, minus 3 by 7. I'm just circling out all the answers. (18 by minus 30 and minus 12 by 20). Okay. Okay. This is 4 by 7 is the answer. So that was question number 4. Let's do question number 5. Question number 5 says, which of the two rational numbers is greater in the given pair? Okay. So first is 3 by 8. The given pair of rational numbers are 3 by 8 and 0. Now clearly we can say that 3 by 8 is greater than 0, because we know that 3 by 8 is a positive rational number and all positive rational numbers are greater than 0. Okay. Part 2 is the two given rational numbers are minus 2 by 9 and 0. Now we can clearly say that minus 2 by 9 is less than 0. Now the question has asked which of the two rational numbers is greater in the given pair. So definitely for the part 1, I am boxing the rational number which is greater. So 3 by 8 is greater. in the part 2, minus 2 by 9 is less than 0, because we know minus 2 by 9 is a negative rational number and all negative rational numbers are less than 0. So hence in this case 0 is the greater rational number. Okay, let's see part 3. Part 3 is minus 3 by 4 and the pairs are 1 by 4. Now clearly we will say that minus 3 by 4 is less than 1 by 4. Why? Because minus 3 by 4 is a negative rational number and 1 by 4 is a positive rational numbers, and we know that all negative numbers are definitely less than all positive numbers. Whether the number is a rational number, fraction, integers, whole numbers, it does not matter. Any negative number is always less than a positive number. So in this case 1 by 4 is the greater rational number. Okay, let's see part 4. The two pair of given rational numbers are minus 5 by 7 and minus 4 by 7. Now in this case both the rational numbers are negative, and we also see that the denominators are same. Denominators of both the rational numbers is 7. So in that case we will only compare the numerators of the rational numbers. Since we see that minus 5 is less than minus 4, this will imply that minus 5 by 7 is less than minus 4 by 7. So the greater rational number is minus 4 by 7. Okay, part 5 is 2 by 3 and 3 by 4. Now we see that both the rational numbers are positive but the denominators are different. So in this case we find the HCF, we convert both these rational numbers to their equivalent rational number so that they both have a common denominator, which will be HCF of the denominators of the given rational numbers. So in this problem the HCF, sorry, not HCF but LCM, we have to convert these two rational numbers into their equivalent form so that both the equivalent rational numbers will have a common denominator as the LCM of the denominators of the given rational numbers. So in this case the denominators are 3 and 4. So the LCM of 3 and 4 is equal to 12. So we have to convert both these rational numbers so that they have denominator 12. Now how do we convert 2 by 3 so that to an equivalent rational number so that the denominator will be 12? We will have to multiply both the numerator and the denominator by 4. Why? Because to convert the denominator 3 to 12 we have to multiply it with 4. So 2 by 3 becomes, its equivalent rational number is 2 into 4 divided by 3 into 4. Similarly, we have to, if we convert the rational number 3 by 4 to its equivalent form so that the denominator becomes 12, we have to multiply both the numerator and the denominator with 3. Why 3? Because to make the denominator 4 to 12, we have to multiply it with 3. That is the reason we have to multiply both the numerator and the denominator both with 3. So this becomes 3 into 3 divided by 4 into 3. So now the rational numbers becomes 8 by 12 and 9 by 12. Now we can see that the two rational numbers have same denominator, which is 12. Now we will just compare by the numerators. We can see that 8 is less than 9. This implies that 8, the rational number 8 by 12 is less than 9 by 12. This implies 8 by 12, the original rational number was 2 by 3. So we can say 2 by 3 is less than, for the rational number 9 by 12, the original rational number was 3 by 4. 3 by 4. So we have 2 by 3 less than 3 by 4. So definitely the greater rational number is 3 by 4. Okay, there is part 6. Part 6. The pairs of rational numbers given are minus half and minus 1. So clearly both the rational numbers are negative. Minus 1 we can always write any integer, we can always write in the rational form where the denominator will be 1. So minus 1 is minus 1 by 1. So both these rational numbers are negative and we see the denominators are different. So we have to convert these rational numbers to their equivalent form so that both the equivalent rational numbers will have a denominator as the LCM of 2 and 1. LCM of 1 and 2 is 2. So we have to convert both these rational numbers to their equivalent form so that both the equivalent rational numbers will have 2 as denominator. So for minus 1 by 2 the denominator is already 2, so we need not do anything for that. But for minus 1 by 1 we have to multiply both the numerator and the denominator with 2 so that the denominator becomes 2. So we get the rational numbers minus half and 2 by 2. Now the two rational numbers have same denominator 2. Now we will compare these rational numbers based on the numerators and we clearly see that minus 1 is less than 2. So this implies that minus half will be less than 2 by 2 and this implies minus half will be less than the 2 by 2, the original rational number was minus 1 by 1. So definitely minus 1 by 1, no, I did something wrong, let me check. Sorry, this was when converting minus 1 by 1 to its equivalent rational number so that the denominator is 2. I multiplied both the numerator and the denominator with 2 and the numerator would be minus 2, not 2. So this will be minus 2 and we can clearly see that 1 is greater than minus 2. So this implies minus half will be greater than minus 2 by 2. So this implies that half will be so this implies minus half will be greater than the original rational number of minus 2 by 2 was minus 1 by 1. So this implies minus half is greater than minus 1. Hence the greater rational number is minus half. Okay, so that was question number 5. Let's do question number 6. Question number 6 is also about comparing two rational numbers. Which of the two rational numbers is greater in the given pair? Okay, so there are a lot of problems. So let's do it. Part 1 is the two given pair of rational numbers. The given pair of rational numbers are minus 4 by 3 and minus 8 by 7. Now we clearly see we are asked to find the greater rational number. Which rational number is larger or greater? Now we see that both the rational numbers are negative but the denominators are different. So we have to find first we have to convert these two rational numbers to their equivalent form so that the equivalent rational numbers will have a common denominator as the LCM of their denominators of the given rational number. That is, we have to find LCM of 3 and 7 which is 21. So we have to convert these two rational numbers to their equivalent form so that they both have a denominator of 21. So minus 4 by 3 will become minus 4. Both the numerator and the denominator has to be multiplied with 7. 3 by 7 and for this rational number minus 8 by 7 we have to multiply to make the denominator 21. We have to multiply both the numerator and the denominator with 3. So we got the new rational pair of rational numbers as minus 28 divided by 21 and minus 24 divided by 21. Now clearly we see that now the denominators are same 21. Now we compare the rational numbers based on the numerators. So we know that minus 28 is less than minus 24. So this will imply that minus 28 by 21 is less than minus 24 by 21. So this implies the original rational number of minus 28 by 21 was minus 4 by 3. So minus 4 by 3 is less than minus 8 by 7. Minus 8 by 7 was the original rational number of the equivalent form minus 24 by 21. So we clearly see that we clearly see that minus 8 by 7 is the larger or greater rational number. Okay, let's do part 2. The pair of rational numbers is 7 by minus 9 and minus 5 by 8. Now first we have to convert the given pair of rational numbers to standard form if it is not already. We can see that the first rational number 7 by minus 9 is not in standard form because the denominator is negative. So let's first convert the first rational number to standard form. So to convert 7 by minus 9 to standard form, we have to multiply both the numerator and the denominator with minus 1. So we have 7 into minus 1 divided by minus 9 into minus 1, and this is minus 5 by 8. So this becomes minus 7 by 9 and minus 5 by 8. Now we can see that both the rational numbers are negative, but the denominators are different. So we have to find the LCM of the denominators, that is LCM of 9 and 8, which is 72. Okay. So now we have to convert these two rational numbers minus 7 by 9 and minus 5 by 8 to their equivalent form, so that the equivalent rational numbers will have a denominator of 72. So to convert minus 7 by 9 to its equivalent form, so that the denominator will be 72, we have to multiply both the numerator and the denominator with 8. Similarly, to convert minus 5 by 8 to its equivalent form, so that the denominator will be 72, we have to multiply both the numerator and the denominator with 9. So now the pair of rational numbers becomes minus 56 by 72 and minus 45 by 72. Now the pair of rational numbers have the same denominator 72. We can now compare by the numerators, and we know that minus 56 is less than minus 45. This will imply that minus 56 by 72 is less than minus 45 by 72. This implies, we can now say, regarding the original number or original rational numbers, minus 56 by 72, the original rational number was 7 by minus 9. This is less than, and the original rational number for minus 45 by 72 was minus 5 by 8. So we can clearly, now we can say that minus 5 by 8 is the greater or larger rational numbers between 7 by minus 9 and minus 5 by 8. Okay, let's do part 3. Part 3 is minus 1 by 3 and 4 by minus 5. Now first we can see that the second rational number 4 by 5 minus 5 is not in standard form. Let's first convert that into standard form. Minus 1 by 3 is already in standard form. So 4 by minus 5 will be, if you multiply both the numerator and the denominator with minus 1, it becomes minus 4 by 5. Now we see that both the rational numbers are negative, but the denominators are different. So we need to find the LCM of the denominators. LCM of 3 by 5 is 15. Now we need to convert these two rational numbers, that is minus 1 by 3 and minus 4 by 5, to their equivalent rational numbers, so that both the equivalent rational numbers will have a denominator 15. So to do that, for the rational number minus 1 by 3, I have to multiply both the numerator and the denominator with 5. So minus 1 into 5 divided by 3 into 5. And to convert the rational number minus 4 by 5 to its equivalent form, so that the denominator is 15, we have to multiply both the numerator and the denominator with 3. 5 into 3. So now the new pair of rational numbers become minus 5 by 15 and minus 12 by 15. So now we see that both the rational numbers have same denominator 15. We will now compare them based on the numerators, and we see that minus 5 is greater than minus 12. This implies minus 5 by 15 is greater than minus 12 by 15. This implies the original rational number of minus 5 by 15 was minus 1 by 3, which should be greater than the original rational number of minus 12 by 15 was 4 by minus 5. So we have minus 1 by 3 is greater than 4 by minus 5. So clearly minus 1 by 3 is the greater rational number. Okay, let's do part 4. Part 4 is 9 by minus 13 and 7 by minus 12. We see both the rational numbers are not in standard form because the denominators of both the rational numbers are negative. First, let's convert both the rational numbers to standard form so that they both have positive denominators. So this will become minus 9 by 13 and minus 7 by 12. That is, whenever you have any rational number where the denominator is negative, let's say I have something like this, a by minus b, where b is a positive integer, so definitely minus b will be a negative integer. Any rational number in the form a by minus b, where b is a positive integer, and of course positive integer, how do we convert this so that the denominator becomes positive? We just multiply, we make the denominator positive, that is b, ignore the sign, and just make the numerator negative, that is minus a. Now if a is already minus 2, then minus of minus 2 will be 2. So for example, 2 by minus 2 by minus 3 is nothing but minus of minus 2 by 3, which is equal to 2 by 3, and 4 by minus 6 is equal to minus 4 by 6. Okay. So we have the two rational numbers in the standard form. We have converted the two given rational numbers to the standard form by making the denominator positive. Now we have both the rational numbers negative and the denominators are different. So we have to find the LCM of the denominators, that is 13 and 12, which is equal to this is this is 13 into 12, whatever this number is, 13 into 12. Into 12. How much is this? We need not calculate the value of 13 into 12. Let it be like this. Okay. Now, so now we have to convert the rational numbers minus 9 by 13 and minus 7 by 12 to their equivalent form, so that both the equivalent rational numbers have a common denominator of 13 into 12. So in that process, what will be the equivalent form of minus 9 by 13, so that the denominator is 13 into 12. It is nothing but minus 9 into 12 divided by 13 into 12, and this rational number minus 7 by 12, its equivalent form, so that the denominator becomes 13 into 12 will be minus 7 into 13 divided by 12 into 13. So now the new pair of rational numbers becomes minus 9 into 12 is minus 108 divided by whatever this number is. I am not computing its value, it is not required, and minus 7 into 13 is minus 91. This is 12 into 13. So now we have two rational numbers where both the denominators are same. Now we will compare by the numerators, and we can see that minus 108 is less than minus 91. This will imply minus 108 divided by 13 into 12 will be less than minus 91 by 13 into 12. Okay, 13 into 12. Okay, now this implies the original rational numbers for minus 108 divided by 13 into 12 was 9 by minus 13. So this will be less than, and the original rational number for minus 91 by 13 into 12 was 7 by minus 12. So we have this relation, and so we can say that 7 by minus 12 is the greater rational number. Okay, let's do 5. 5 is 4 by minus 5 and minus 7 by 10. Now we see that the first rational number 4 by minus 5 is not in standard form, as the denominator is negative. So let's first make the rational numbers, first rational number in standard form. This will be minus 4 by 5. So we have now the rational numbers minus 4 by 5 and minus 7 by 10. We have to compare them. Both the rational numbers are negative, but the denominators are different. So we have to find the LCM of the denominators, that is LCM of 5 and 10, which is 10. Now we have to convert these two rational numbers to their equivalent form, so that both the equivalent rational numbers will have a common denominator of 10. To do that, for the first rational number, we have to multiply both the numerator and the denominator with 2. And for the second rational number, to convert it to its equivalent form so that the denominator will be 10, we have to do nothing because the denominator is already 10. So this is minus 7 by 10. So now we got the new pair of rational numbers as minus 8 by 10 and minus 7 by 10. Now since the denominators are same, we will compare by the numerators, and we see that minus 8 is less than minus 7. So this will imply minus 8 by 10, the rational number minus 8 by 10 will also be less than the rational number minus 7 by 10. And we know that the original rational number of minus 8 by 10 was 4 by minus 5. So it should be less than the original rational number of minus 7 by 10 was minus 7 by 10 only. So we have this. So clearly minus 7 by 10 is the larger rational number. Okay, let's do, we have part 6. Part 6, the rational numbers, pair of rational numbers are minus 12 by 5 and minus 3. Now minus 3, we can write it as minus 3 by 1. We can see both the rational numbers are negative, but the denominators are different. So we have to find the LCM of the denominators, that is LCM of 5 and 1, which is 5. Now we have to convert the given rational numbers to their equivalent form so that both the equivalent rational numbers have a common denominator of 5. So we will have minus 12 by 5 will remain minus 12 by 5 because the denominator is already 5, and minus 3 by 5 will become minus 3. We have to multiply both the numerator and the denominator with 5 to make the denominator 5. So we have this. So the new pair of rational numbers become minus 12 by 5 and minus 15 by 5. Now the rational numbers have the same denominator 5. We will compare based on their numerators, and we see that the numerator minus 12 is greater than the numerator minus 15. This will imply that the rational number minus 12 by 5 is greater than the rational number minus 15 by 5. So finally we will get that the original rational number of minus 12 by 5 was minus 12 by 5 only, and the original rational number of minus 15 by 5 was minus 3. So we clearly see that minus 12 by 5 is the greater rational number. So this brings an end in solving the question number 1 to 6. 1 to 6, and in the part 2 video I will solve the question number 7, the remaining question number, which is 7 to 10. I hope this video was beneficial. If it is, please like it, share it with your friends, and once again please support me by subscribing to my channel, and please do not forget to press the bell icon so that you will be notified by my future videos. In the next video, which will be part 3, I will solve the remaining problems 7 to 10 of exercise 1A. So please stay tuned for the next video, and until then, take care and bye.